All right, let's move into predicting and naming ionic compounds. So rules for naming binary compounds, which are just compounds that are composed of a metal and a nonmetal. Oop. Okay, so binary just meaning two, so one metal, one nonmetal. That's how we're getting that name. Okay, so we always name the metallic ion first, followed by the non-metallic ion. Okay, and you can't forget to change the ending of the non-metallic ion to IDE. Okay, so that's going to be incredibly important here. So metallic ion always comes first, non-metallic ion always comes second, and your ionic compounds should always end in IDE. Ionic compounds are always going to start with a metal or a cation, which is a positive ion.
I have no garbage. Okay.
Now the reason why it's saying a metal or a cation is because there is, like most of the time, your ionic compound will start with a metal. However, there is an exception where you can have a ionic compound that starts with ammonium, which is NH4 1+. Okay, now the reason why this is, even though nitrogen and hydrogen, those are both nonmetals, because this polyatomic ion has a positive charge to it, that's why it counts as an ionic compound, because all ionic compounds, they start with either a metal or a cation. Okay, so what we can say is ammonium, that is a polyatomic ion that acts like a metal. And it acts like a metal because of that positive charge on it. All right, so for the two examples that were given here, the first one is a classic one that we've already said here, but I'll go over it. So Na, that is the symbol, if you look on your periodic table, that is the symbol for sodium. So switching this formula from a formula to a name, okay, we're going to write sodium, and then Cl, that is the symbol. If we look over here, that's the symbol for chlorine. However, keep in mind that we always have to end our ionic compounds names with the ending IDE. So instead of saying sodium chlorine, I'm going to change that INE ending to IDE, because all ionic compounds end with IDE. Moving on to MgO, switching that from a formula to a name. So Mg, that is the symbol, let's see, for magnesium. So I'm going to write magnesium. And then O, if we look that up on our periodic table, that is the symbol for oxygen. However, we can't just call it magnesium oxygen because it has to end in IDE. So this is going to turn into magnesium oxide. So we're taking that ending of oxygen and switching it to IDE. Okay, and since we've done sodium chloride quite a bit, I'll start off this first practice question just to give you a little bit more information or a few more examples of how to name ionic compounds. So with this symbol Ag, if we take a look at our periodic table, let's get rid of these. So Ag, that's right here. So that's the symbol for silver. So naming this, I'm going to say silver. And then S, if we look on our periodic table, that is the symbol for sulfur. But remember, we got to take that ending and change it to IDE. So we're going to not call it silver sulfur, we're going to call it silver sulfide. Okay. With the next one here, okay, Al, again, if we look on our periodic table, oh, that's right here. That's the symbol for aluminum. So I'm going to call this aluminum. Okay, and then Cl, we've already found that. That's the symbol for chloride. Or it's a symbol for chlorine, but we got to switch the ending to IDE, so it's going to be aluminum chloride. So again, with these practice questions, please refer to the lesson guide to see what is assigned to help you get these concepts. Okay, so first what we were doing was we were going from a chemical formula to a name. Now we're going the other way around. We're going to be writing a formula from the name of an ionic compound. Okay. So what we're going to do first is we're going to write the two ions. Okay, now remember, ionic compounds, they're made up of a metal that comes first, forever and always, and then a non-metal comes second. Okay. So this is important, so let's make sure we highlight this. Okay, step number 2, we're going to crisscross the charges. And the reason why we want to do this is because we want to make sure that our compound has a balanced charge or a neutral overall charge. And then step 3, we're going to reduce the charges to the lowest ratio if that's necessary. Okay. So for example, we have calcium chloride. So if I look on my periodic table, so the symbol for calcium is right here. It's Ca. And then the symbol for chlorine is right here. So Cl. Now, before I go back to my notes, I'm going to examine. Okay, calcium likes to have a charge of +2. And chloride likes to have a charge, I'll get rid of this, of -1. So going back to my notes, I'm going to capture all of this. So calcium chloride, and then I'm going to write the charges over top. So calcium like to have a charge of +2, chloride like to have a charge of -1. So at this point, we've finished step 1. Now, this is going to be step 2. So I always ask myself, okay, 2 minus 1, does that equal 0? If the answer to, if your charges equals 0, if that answer is no, you got to do the crisscross thing that the notes are referring to. So what the crisscross thing is you take the number, not the charge, but just the number, and you just take it and cross it over. Same here with the 1, right? However, you don't have to write the 1, okay? And you would never write the negative for the subscript, but you can if you want, okay? But most of the time, the 1 is not written explicitly. So now, if we check out to see if the charges are balanced here, so calcium still has that 2+ charge, okay? But now we have 2 because there's 2 chlorides, and we're going to times that by the charge of chloride, which is -1. Okay, so 2 times -1, that's -2. 2 plus -2 does equal 0. So that is our balanced compound. Okay, so CaCl2, that has a net charge of 0. Moving on to aluminum oxide. So the symbol for aluminum, let's see, that's Al. The symbol, actually, hang on, before I move on, aluminum likes to have a 3+ charge. And then with oxide, that's O, it likes to have a -2 charge. So let's bring that over here. So AlO, aluminum likes to have a +3 charge, and oxygen or oxide ions like to have -2 charge. We know that that doesn't equal 0, so we have to do the crisscross applesauce. Remember, we only bring the numbers down, not the charges. So I'm going to bring down 2 and 3. So let's write this a bit more neatly. So Al2O3. If you want to check out how the charges are working out, so we have 2 aluminums that have a 3+ charge, plus 3 oxygens that have, or oxide ions, sorry, that have a -2 charge. So 2 times 3, that's +6. 3 times -2, that's going to be -6, and that does equal 0. So this is a balanced compound. Okay, so what I'm going to do is I'm actually going to put a box around my final answer just so it's a bit more clear. And let's do that over here as well. Okay. Okay, last one. Zirconium sulfide. So, looking at my periodic table, well, sulfide, I know that's just the ion form of sulfur, and sulfur likes to have a -2 charge. So let's get rid of this. Okay, and the symbol for sulfur is S. Now let's look for zirconium. Oop, let's get rid of this. So zirconium, that's going to be right here, and its symbol is Zr, and it likes to have a 4+ charge. So let's write that out. So zirconium sulfide, +4, -2. We know that that doesn't equal 0. So we got to do crisscross applesauce. So I'm going to bring down the 4 and the 2. I'm bringing down the numbers but not the charges. Let's clean that up. We have zirconium 2 and then sulfide 4. Now looking at this here, like because we did the crisscross applesauce thing, the charges are all going to balance out. This does have a net charge of 0. However, we don't have the lowest ratios. If you look, we can divide both of these by 2. So that's what we need to do because ionic compounds always have the lowest ratio possible. Right. So our final answer, I'm going to have to write it over here, is going to be zirconium. So 2 divided by 2, that's just 1, and you don't have to write the 1. 4 divided by 2, that's 2. And that's my final answer. Okay, so for checking to make sure if your compound always has the lowest ratio, you're just asking, can both of the numbers that represent how many atoms of each element there are, can those numbers be divided by a certain number and still give you whole numbers after division occurs? If yes, then make sure you do so that you get the lowest ratios. Moving on to multivalent metals. So what multivalent metals are just metals that have more than one possible charge. Okay. So for example, iron has 2 possible charges, or 2 ions. There's iron 3+ and iron 2+. So looking at your periodic table, we can find iron here, and it lists both the charges. Now the 3+ charge is more common, that's why it's listed first, and then the 2+ charge for iron is a little less common, so that's why it's mentioned second. Okay. So the most common ion is always going to be the first. Okay. And when we're writing the name of an ionic compound that has a multivalent metal, we need to write the name using Roman numerals in order to denote the ion charge. So it's very critical that you understand that the Roman numerals indicate the charge of the multivalent metal. They do not indicate how many atoms of that certain metal that you have. So the Roman numerals for 1 through 5, it's going to be 1 is going to be this, 2 is going to be that, 3 is going to be this, 4 is this, and 5 is that. Okay. So for some examples here, we have iron 3 oxide. So this means that iron has a 3+ charge. Okay, so writing out the formula, I'm going to write iron because that's the symbol for iron. Oxide, the symbol is O. Okay, it has a 3+ charge on the iron, and oxygen, if you want to look it up on the periodic table, that has a 2- charge. Now we know that that doesn't equal 0, so that's why I'm going to do the crisscross applesauce. So I need to keep this neat, so I'm just going to write the numbers. I'm not going to draw the lines. Okay, so now at this point, since we have 2 irons that have a 3+ charge, and then 3 oxide ions that have a 2- charge, well, that's 6 minus 6, which does equal 0. So now this works out. Okay, chromium 3 bromide. Let's find both of those here. So chromium can be found right here. Okay, and it's a multivalent metal because it has more than one option for what its charge could be. Okay, so the symbol is Cr. And bromide, it's just a bromine ion. That's right here. So the symbol is Br. It likes to have a -1 charge. Now since it's chromium 3, that means our chromium ion is going to have a 3+ charge. And then bromine, or the bromide ion, that only has one possibility. It's only going to be a -1. Okay, so we know that doesn't equal 0, so crisscross applesauce. So 3, and the chromium is going to have a little invisible 1 coming after it. Okay, so what's happening here is we have a 3+ charge coming from the 1 chromium. We have plus 3, because we put 3 bromide ions, times -1, because each bromide ion has a -1 charge. Okay, so we have 3 times -1 is -3, which does equal 0, so that's done. Okay. For our next example, we have Cr2S3. Okay, so we know that Cr from our previous questions, that's going to be chromium. However, we got to figure out what charge this is going to be. Okay, so our options for chromium, okay, it's either going to be 3+ or 2+. So if I take a look at the sulfur first, right, to help me figure out which of the two possible charges for chromium there's going to be, I'm going to notice that sulfur, I'm starting there just because we know that one for sure. It has a -2 charge. So -2, and there's 3 of them. Okay, so that's going to give me -6. Now with chromium, right, we have 2 of them, and we don't know what the charge is. Okay, so we have 2x, but we know we want this equation to equal 0. So if I was to do a little bit of algebra, which I'll have to bring that out over here, so 2x minus 6 is equal to 0. If I add over that 6, so we get 2x is equal to +6, divide both sides by 2, we have x is equal to 3. So that's chromium 3+, or chromium 3 sulfide. For the last one, we have PbO2. So looking at the periodic table, Pb, that's going to be lead. So it can either have a 2+ or a 4+ charge. Okay. O, I'm starting there just because I know for sure that that can only have a -2 charge. Okay. So I have 2 oxides at a -2 charge. I have 1 lead ion, but I don't know the charge of it. So cleaning this up a bit, I put equals 0 because I know I want this compound to have a neutral charge. So cleaning this up, we have x minus 4, because 2 times -2 is -4. Okay, if I add over the 4, x is equal to 4. So the charge on lead is 4. So lead 4 oxide. Okay. So some reminders here with multivalent metals. Okay, you always need to put brackets around the Roman numerals that indicate charge. Okay, and the Roman numerals indicate charge. So that's very important that you know that Roman numerals indicate charge, not the amount of atoms. Okay, and the reason why I always set my equations to equal 0 is because you always want to create neutral ionic compounds. So what I'm doing here is I'm just taking what I've been saying as I've been solving these problems and just writing it out. So make sure you also get these notes down too. Moving on to polyatomic compounds. What this means, so poly just means many. So polyatomic compounds, those are going to have 3 or more different types of atoms in them. So this means that they could have a polyatomic ion in them. General trends in polyatomic ions, most of these ions are going to either end in ate or ite. So what you can do is if you look at your periodic table and go to the table of polyatomic ions there, which should fix that, most of them, not all of them, but most of them either end in ate, ate, or ite, ite. Okay, there is one positively charged polyatomic ion. It is ammonium, which is NH4, 1 plus. Ooh. And 2 of the ions listed in the polyatomic ions. Actually, hang on 1 second. Let's take a look at this. I believe there's actually more than 2. So there's carbide, there is hydroxide, persulfide, and peroxide. Those are going to be our exceptions. Those are the polyatomic ions that do not end in ate or ite. Ate or ite. Okay, so let's fix these. So there's 4 of these ions that end in ide. So hydroxide, carbide, peroxide, and hydrogen sulfide. So for naming rules, make sure you name the metallic ion first, then the polyatomic ion. So those are the ones that can be found on your periodic table. They're right here. Okay, with writing formulas, make sure you write the 2 ions, so the cation and the anion, and balance the charges. Use brackets if there is more than 1 polyatomic ion. If there is not more than 1 polyatomic ion, do not use the brackets. So for example, magnesium hydroxide. So magnesium, the symbol for that is Mg. For hydroxide, the symbol for that is OH1 minus. So magnesium likes to have a 2 plus charge. Hydroxide likes to have a 1 minus charge. Let's do the crisscross applesauce. Because we're going to need more than 1 hydroxide ion. Because it's a polyatomic ion, I got to surround it with brackets and then write a 2 to denote that there are 2 hydroxides so that this does balance out. Okay. With zinc chloride, so the symbol for zinc, if we look here, zinc's going to be Zn, and then chlorite is going to be ClO2 1 minus. So So zinc likes to have a positive 2 charge. Chlorite likes to have a minus 1 charge. We got to do crisscross applesauce because 2 minus 1 does not equal 0. So now this does equal 0. So we're all good on that. Okay. Moving on to this. The symbol for Al is going to be aluminum. Let's go and check out aluminum. It's going to be here. I notice that it's not a multivalent metal, so I don't need to worry about Roman numerals. Okay, so I'm going to write aluminum. Now, SO4. So how I know that this is a polyatomic ion is because it's surrounded with brackets. I also know that there's a polyatomic ion here is because there's more than 2 elements in this entire formula here. So SO4, if I look at my list of polyatomic ions, okay, I'm going to find it right here. So that's sulfate. So when you're writing the names of the polyatomic ions, you do not change them from how they are written in your periodic table. So this is going to be aluminum sulfate. Okay. Moving on. Potassium phosphate. Oh, let's check this out. So phosphate, that's your indicator. Okay, you got a polyatomic ion. That's PO4, 3 minus. Now potassium, that can be found right here. So it likes to have a 1 plus charge. The symbol for it is K. So K, and then phosphate likes to have a plus 1 charge, likes to have a minus 3 charge. Okay, so we know 1 minus 3 does not equal 0. Therefore, we got to do crisscross applesauce. So 3 times 1 is 3 minus 3. Yep, that does equal 0. So that is complete. Okay, and since we only have 1 phosphate ion, I do not need to put brackets around it. All right. Last but not least, we have K2S2O3. So because there's more than 2 elements, I know that there is a polyatomic ion somewhere in here. Okay, so let's take a look at my list of polyatomic ions and see what I can find here. Okay, so S2O3, that's going to be thiosulfate. Okay, K, we know that's potassium because we just looked up what potassium was. So let's write this down. So potassium, and reminder, you write the polyatomic ion name exactly how you see it on your periodic table. So thiosulfate. You do not change the ending of polyatomic ion names.